All right, today we're going to learn about inverse variation. Before we do, we're going to briefly talk about direct variation. So this is just something that you guys covered in Algebra 1. So it's just been a while since that happened. So we're going to kind of understand what it means to be directly related to each other. So by definition, if y varies directly with x, then one thing happens. As the x value increases, and so this part goes up here, so we'll write the actual word increases, then the y value also increases. Okay, so basically, if one goes up, the other one has to go up. Okay, and then on the other side as well, if the x value decreases, then the y value also decreases. Okay, so that's what we need to understand about direct variation. They go the same direction. As one value increases, the other increases, or if one decreases, then the other also decreases. Okay, and so there's an equation that we use for direct variation. So the direct variation equation is y is equal to k times x, where k is known as the constant of variation. We need to understand that vocabulary. So k is the constant of variation. All right, so this asks, what does this equation remind you of? It should kind of remind you of y equals mx plus b. Okay, but what's the difference about this equation over here, y equals kx, right, is that it doesn't have that part, the b part. Okay, so the b, remember, is the y-intercept. Okay, so if it's not written in our equation, then direct variation should always have a y-intercept of 0. So the y-intercept is always 0. Okay, now how do I find the constant of variation, or the k value? Okay, here it can be found by this equation. Okay, k equals y divided by x. So now this is where things get confusing, right? Because we have an equation here. So this is just the equation. How do I write the expression, right? And then we have these same letters reorganized, but that's how we find the k value. Okay, and so I'll try to explain, and I'm going to use these two equations whenever I'm solving this, okay? But this is always going to happen first. I want to find the k value first, okay? So let's move down to the examples down here. So example 1 says to underline vary directly. So we can underline varies directly. So this says Julio's wages vary directly with the number of hours that he worked. Okay, so this kind of separates our two variables, right? So the Julio's wages is going to be represented by y. Okay, it's always y varies directly with x, and then the number of hours that he works is going to be represented by x. Okay, and so here we're going to basically write an ordered pair. It says if his wages for 5 hours, hours is represented by x, are 29.75. So that's my y value because that's how much he made. It says how much will they be for 30 hours. So our ultimate goal is to find how much is he going to get paid for 30 hours, right? So it gives us one complete point and then half of the other one, okay? So we're going to take the complete point, 5 and 29.75, and we're going to find the k value using that point, okay? So to find the k value, remember, that's where I said we're going to do this first. We're going to use this equation. K is equal to y divided by x. So here I'm going to say k is equal to, and then my y value is 29.75 divided by my x value, which is 5. when I divide those two, then I get 5 divided by 5, I get 5.95. Okay, so my K value is 5.95. So that's the very first thing you always do, is find the K value. Okay, the second thing that I do is I'm going to write my equation. So that's where I am going to use the equation. So this is second, actually. Okay, so I'm going to write my equation in the form of y equals kx. So for my equation, all I do is plug in y is equal to 5.95 times x. Okay, so I found my K value first, I wrote my equation second, and now I'm going to solve my problem with this equation that I just wrote. Okay, so it says find Julio's pay for 30 hours. Well, I've already completed this ordered pair right here, so I know the x value, and I'm trying to find the y value. So all I need to do is use the equation, y equals 5.95, and I substitute what I know. I know that he is going to work 30 hours. And so then from here, I do 5.95 times 30, and that gives me an answer of 178.5, and you can actually, since it's money, put 5 zeros. So $178.50 is what he would get paid for 30 hours of work. Okay. Let's move on to example 2. It says if y varies directly with x, okay, y varies directly with x, and y is 28 when x is 7, so I'm going to write an ordered pair right here. So, 7 is the x value, 28 is the y value, and it says find x when y is 52. Okay, same concept. We're going to break this down into those 3 steps. The first thing I want to do is find k. So k is equal to, and I take the full ordered pair and I divide those two numbers. Y divided by x. So 28 divided by 7. So 28 divided by 7 gives me a k value of 4. Once I have the k value, I now write my equation. Y equals 4 times x. Okay. And then the third thing I do is I solve my problem. So now I'm going to use this other ordered pair that I only have half of, and I'm going to substitute what I know. I know that y is 52, and that's going to equal 4 times x, or 4 times a number. So then how do I solve this? I simply divide both sides by 4. And so x is equal to 13. Okay, so then that ordered pair would be 13 and 52. All right, so you should see kind of a pattern right here, right? And then the last example for direct variation. A standard shower head uses 18 gallons of water in 3 minutes. Complete the table below that shows that gallons used y is a function of time in the shower. Okay, so here again we have an ordered pair, but instead of writing an ordered pair, they have a table. So I know in 3 minutes, here's my 3 minutes, I use 18 gallons. Okay, this is the number, or the numbers that I'm going to use to find k, because it's the completed ordered pair. So k is equal to 18 divided by 3, and that gives me 6. The second thing I'm going to do is write the equation, y equals 6 times x. Okay. And then, I can put 6 over here. And then I'm going to use this equation to fill out the rest of the table and solve part C. Okay, and it will be pretty simple, right? So what I like to do is, one, we can come down here and do 6 times and then plug in these numbers manually, and that gives me 36, right? And then I would have to do the exact same thing again, 6 times 9, right? And get all these numbers. Now, instead of doing this by hand, I can always use Desmos and plug in this equation. So if I come to Desmos and I say y equals 6x, and then I hit the little edit cog right here and go to table, then I can just start entering in numbers. I needed 6, gave me 36. The next number I need is 9 and 54. And then it goes to 12, 15, 20, 25, and 30. So this is helping me fill out the rest of the table. So it's 9, 54 is the next, and then 12 and 72, and so forth, right? 15, 90, 20 and 120, 150, and 180. Okay, so that helps me kind of find any value I need. And so that comes in handy somewhat down here, right? Now here's a little bit different, actually. I thought it was the same thing. Again, I plug in what I know. I know 270 gallons is actually my Y value. So I use this equation, 270 is equal to 6 times X. And then I simply divide 6 to both sides. So then I have 270 divided by 6. And that gives me 45. So this would be 45 minutes in the shower. Okay, and that's direct variation. So, inverse variation. Okay, most of us think of inverse. If you don't, think of inverse as kind of like the opposite, right? Not necessarily the opposite, but it undoes what's going on, right? So if y varies inversely with x, then as the x value increases, then the y value decreases. Okay, so if one value goes up, the other goes down. So then right here, if the y value decreases, then the y value increases. So as the x decreases, then the y increases. So basically what you need to know is they go in different directions, right? One goes down, the other goes up. Okay. So again, we have an equation, right? So this is always going to be the second thing we do. How we find x is going to, or k is going to be the first thing we do. So I'm going to talk about this first. How do we find k, right? K is still the constant of variation. To find k, we're going to use a different formula right here. K is going to be equal to y times x this time. Okay, so I'm not dividing, I'm multiplying now. So we multiply. And then when I write my equation is going to look different than the direct variation. It's going to be y equals k divided by x. Okay, and again, k is still known as the constant of variation. All right. So I'm going to kind of skip this. I'm going to go to my examples. So example 1, I'll come back to 1 through 4 up here. Example 1, it says the number of songs on an iPad varies inversely, so I'm going to underline that, with the average size of a song. Okay, so again, we find varies inversely. The first part of this is going to be known as y. The second part is going to be my x, right? So what comes before is y, what comes after is x. So the number of songs is going to be y. and the average size of a song is going to be X. So just to figure that out, I'm going to use S for size and N for number. So just S and N are my X and Y, right? So it says an iPod can store 2,500 songs. So that's the number of songs, right? So that gives me 2,500 as the Y. When the average size of a song is 4 megabytes. So there's 4. So this is my completed ordered pair. So the first thing I'm going to use that for is to find the K value. Remember, the K value is different for inverse variation. I am going to multiply those two numbers. Okay, so when I multiply those two numbers, 4 times 2,500 gives me 10,000. Okay, the second thing I'm going to do is write my equation. So my equation is going to be y equals 10,000 divided by x. Okay, if you want to use S and N, then it's going to be S is equal to 10,000 divided by N. Okay, N is X, right? Oh, wrong way. My apologies. N is actually the Y and S is the X. Okay, so if you want to use those variables, you can. If not, you would have to use X and Y. Either or works the same. And then I'm going to use that equation to figure out how to solve this. So it wants us to find how many songs from 5 megabytes. So megabytes is the size, which is my X, right? So then I have the number of songs is equal to 10,000 divided by 5. So when I do 10,000 divided by 5, I get the number of songs is 2,000. Okay. And then example 2, if y varies inversely with x, and it gives me an ordered pair right here. When x is 4, y is -3. Find the constant of variation and the equation relating x and y, then find y when x is 6. Okay, so these are the ordered pairs I have. I'm going to first use the completed one to find the constant of variation, which is k. So I do 4 times -3, which gives me -12. The second thing I'm going to do is write my equation, y equals -12 divided by x. And then the last thing I'm going to do is use that equation to find my missing value. So I know x, so I substitute x in, and then y is going to be equal to -2. So if I wanted to complete that ordered pair, this would be now -2. Okay, and I can do this in my head, fairly simple. You can also plug this in the Desmos, right, and go to your table to figure that out. But I'm going to give you that example here in example 3. It says the diameter of a string of a violin varies inversely with the frequency of the pitch. So this is going to be y, and this is going to be x. Okay, if the diameter is 5 millimeters, the pitch is 500. So here's my completed ordered pair, right? Again, it's as a table. So I find 500, and I go ahead and put 5 there. Okay, it says complete the table that shows the frequency y is a function of the diameter. So the first thing I'm going to do is find k. How do I find k? K is equal to 500 times 5, and that gives me 2,500. Then I write the equation. Y is equal to 2,500 divided by x. Okay, and then the last thing, okay, I need to do is one, it said complete the table. Sorry, two things, complete the table and find the diameter when it, or the frequency when the diameter is 20. So again, since I have a lot of values to enter in, I'm going to plug this into Desmos. So I come back to Desmos, clear that out, and I say y is equal to 2500 divided by x. And then I'm going to go to a table. And then I'm just going to plug in 100, 200, 500, and so forth. So we have 100, 200, 200, 500, 1,000, 1,500, 2,000, and 2,500. Okay, and so you can kind of see the y values for there. So we have 25 right here, 12.5 for 200. We have 5 and 2.5 for 1,500. 1.6 repeating, 1.25, and this one was 1, right? So I completed the table using this equation and Desmos, right? And then I'm going to use this equation and plug in what I know. I know the y value is 20. So I put 20 is equal to 2,500 divided by x. Okay, so here's the tricky part. Okay, how do we solve this problem? I have to get rid of x in the denominator. So theoretically, okay, or mathematically, we first have to multiply both sides times x. That will get rid of the x in the denominator. Okay, and then I have a new equation. And then now to solve this, I simply divide 20. Okay, and so what that gives me is 125. Okay, so if you ever get to a point like this, all you have to remember is just take your k value divided by the y value that it gives you, because that's essentially what's going to happen. Okay, you don't have to show this work. Just take 2,500 divided by 20, and that'll find your x value. All right. Now coming back up to this part, this is just identifying, right? So I'm looking at identifying if these are direct or inverse. So I'm just going to use a D or an I to do this. So it says the time completed to complete a job varies blank with the number of workers doing it. So all this is kind of theoretical, right? If it takes me a certain time to complete a job, let's say cleaning my room, okay, right? If it takes me 10 hours to complete cleaning my room, and it's just me, if I have help from my sister, then theoretically the time it takes to complete that job goes down, right? So if the number of workers goes up, the time goes down. So those go in different directions. So this one should be inverse. And then the time it takes to complete a specific trip varies blank with the speed of your travel. Okay, so again, we got the time and the speed depending on how you look at this, right? If you drive really fast, then the time it's going to take to get to a destination is down. So again, this is inverse. And you can do this the other way, right? We can say, hey, if I drive really slow, so that means I have a down arrow here, then it's going to take me a long time to complete that trip. Okay, so you can look at it that way as well, right? So that's another I. Number 3, the cost of gas on a trip varies blank with the length of the trip. Okay, so the length of the trip, let's say the length is very long, then the cost of gas is going to be a lot more, right? So those two go in the same direction. Those two are both direct. The number of people invited to dinner varies with blank with the number of pieces of silverware used. Okay, so both of these, if I have more people invited, then I'm going to need more silverware. So again, those go in the same direction. And so that's both direct. And that's direct and inverse variation.